Hi friends, we are continuing with force and laws of motion. Okay, now in the last class we studied about the third law of motion. Second law of motion. Okay, today we are going to study third law of motion. Okay, now in the first law of motion we got the definition. Second law of motion we got the equation of force. Yes, force equation, that is. Okay, now this third law of motion, okay, what actually there in it, let's see. Okay, now here actually while telling about this third law of motion, it is very important, okay, law in our day-to-day life while talking about. Okay, that is, it is very much useful, and many studies, okay, many things depends on this, okay, third law of motion, especially while telling about the space research. Okay, in space research you know that, okay, without rocket the space research, okay, is not possible. Okay, that is launching of rocket is launching of a satellite is not possible. Okay, now so okay, for this all this purpose actually the third law of motion is what using. Okay, how it is using, let's see now. Okay, now the third law of motion actually what it states, okay, when one object exert a force on another object, okay, the second object instantaneously exerts a force on the first. You may know this. Okay, that is here when one object exerts a force on the other object. Okay, now instantaneous at the same moment, okay, that object is applying a force on the other objects. Understand? That means when we are applying a force, now suppose we are applying a force on the wall. Okay, now when we are applying a force on the wall, okay, now that wall instantaneously apply a force on us. Understand? Okay, this is what the third law of motion telling. Getting? Understand all of you? Okay, that is if, okay, force is applied on one object, that object instantaneously will exert a force back on the first. Okay, this is what actually the, okay, third law of motion. Okay, that is, okay, now what actually we have to understand about the forces here. Okay, first thing is that, okay, these two forces are always, okay, equal in magnitude. Okay, what will be the magnitude will be equal in magnitude. Okay, but opposite in direction. You know that when the first body is applying a force on the second body, the direction is from first body to the second body. Then the second body, the instantaneously at the same time second body is applying a force on the first body. Correct? Now the direction is in the opposite direction because the force is applying from the second body to the first body. Understand? So, but here the magnitude is same. Okay, this both the force magnitude is remain same. Very much you have to understand it. Okay, now these forces act on different objects and never on the same objects. That is other thing, because now when we are pushing on the wall, okay, we are applying a force on the wall. Correct? So one force is applied on the wall. At the same time, wall is applying a force on us. Getting? So now the force of the wall is applying on us. Understand? So the force is not applying on the same object. Okay, it is applying on the acting on the different objects. Okay, now the other thing is that, okay, the two opposite forces are known as the action and reaction forces. Yes, these two forces are known as the action and reaction. That is very important. Okay, now we are acting a force on the wall. Understand? This is the action force. Why it is the action? Because we started. Correct? Okay, we are applying a force on the wall. Actually, wall was remain there only. Okay, when we applied a force on the wall, okay, at that time that wall, okay, applied a force on us. Understand? So the force applied by us on the wall is the action force. Okay, when that at that time the force applied by the wall on us is the reaction force. Understand? So there is an action force and a reaction force. So understand all of you these concepts. Okay, that is, okay, first of all, that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. It is not the, it is a statement, but the definition is, other definition is there. Okay, now the two forces, the very important thing is that these two forces, okay, are always equal in magnitude but opposite in direction. Sure. The other thing is that, okay, this force acts on different objects, never on the same objects. Okay, you may understand this. The other thing, that is the two opposite forces are known as action force and the reaction force. Now here we can understand this, okay, using an experiment of this spring balance. Now you take the two spring balance, one is of A and other is of B. Now here the spring balance B is fixed on the wall. Understand? Okay, now in the spring balance A is in our hand. Now what we do, we will connect these two, okay, spring balance as shown in the figure. Then we will start to pull the spring balance A. While we are pulling the spring balance A, we can see that okay, as much the spring is moved in the A, okay, spring balance A, that much will be moved in the spring balance B. Understand? That means, okay, it means that, okay, that is when, that is whatever the movement in the spring B is because of the force applied by the spring balance A, that is applied by us, correct? But, okay, the whatever the movement of spring in the B, it is because of the action of, that is reaction of the spring balance B on B. Understand? So here we can see that it is a very good experiment to understand the action, reaction and equal and that is reaction force. Okay, so here the spring balance A is applied the action force and the spring balance B is of a reaction force. Now here you can understand that the magnitude, the movement of the spring, the quantity of the spring which is moved shows the, okay, the magnitude of the force. There you can see that the magnitude of force in A and B is same. Okay, also, okay, you can see that it is opposite in direction. That is, okay, the B is, the force of B is applied, okay, from A to B, correct? At the same time, the force of A is applied from B, this, that is B to A. Understand? That is in opposite direction, it is applied. Sure, all of you? Okay, this is what actually the action, reaction and opposite and third law. Now in a simple the statement we can put it, okay, that is of okay, for every action there is equal and opposite. Now what is the third law of motion? Then you have to state this much only, that is for every action there is equal and opposite reaction. Understand? You don't remember that, you just remember that somebody slapped you. Okay, now what you will do? What you will do? You just okay, by crying you will go away? Not, no. Okay, you will also give a slap to the person who slapped us, correct? Okay, so from this we can understand that okay, this is actually what actually done there is, okay, for an action, okay, that is there was action. What is the action is a person slapped you. Okay, now the reaction is that you slapped him also. Okay, so that is the action and the reaction. Okay, so however, it must not be remembered that the action and reaction is also on the, okay, yes, it must be remembered. Okay, it is always acting on the two different objects, not on the same objects. Now there are, we already told that there are many uses, that is application is there of this third law of motion. Okay, let us see some application. Now you know that we walk on the ground. Okay, now we walk on the ground. How it is enable us to walk on the ground? Actually it is because of the action reaction, that is third law of motion. When we are walking on the road, we are walking on the ground, actually with our toes we are applying a force on the ground, correct? While you are walking you will understand it. At the same time, what actually the earth is doing, earth is applying an equal force on the leg, on our body, so that we are enabled to lift our leg, understand, because of the earth's force. We are applying a force on the earth, but at the same time earth is applying a force on the leg, so that the leg moves upward, understand? Now you can see that if you are very tired, if you are very tired, you know that you can't walk. Why you can't walk? Yes, here you have to understand that when you are very tired, you are not able to apply a force on the ground, so that the earth cannot act a reaction force on you, so you cannot. Now you will think like that, now because of the earth's force our leg is moving upward, why don't, because of our force earth is not moving backward? Look, here you have to understand that the magnitude of the force is same, that is correct, and it is in the opposite direction also, but due to these forces, there is acceleration, there is movement, understand? Now how this is happening? Here comes the matter of mass. Even though the equal force is applying on it, whichever the mass is less, that will start to move, understand? Whichever the mass is greater, that will not move, that will be remain there only, understand? That's why now here you know that because we are applying a force on the earth, earth is not moving backward because of the earth is having a greater mass. But at the same time the earth is applying a force on our leg is able to move forward, understand? So that because the leg is having, or we are having very less mass related to the earth. Many such examples are there. That is so it is very important note that even though the action and reaction forces are always equal in magnitude, these forces may not produce acceleration on equal magnitudes. This is because of each force act on the different object that may have different masses, understand? It is always producing an acceleration because of the difference in the masses, even though it is the magnitude is equal. I hope you understand. Now we will move to the other one example. It is of the gun, rocket. Example is mini. In this you know that while the gun is fired, you know that, but it exerts a force on the bullet, but the spring in the gun exerts a force on the bullet, understand? So because of that the bullet move forward, understand? But when you can understand that when the spring is applied a force on the bullet, at the same time bullet is applied a force on the gun, so that the gun started to move backward, so it is called the recoil, recoil velocity. The velocity through which the gun moving backward is called a recoil velocity, because of the recoil force applied by the bullet, understand? Now so in this case, how it is happening? Now you know that the gun will not move very much backward, so you know that how to use gun also. While using gun we must have to place it in a particular way on our shoulder, otherwise we will die because of this recoil velocity. That is very important. But now you know that here the bullet will move a greater speed, but that much speed won't be there for the gun. Why it is? Because you know here that the mass of the bullet is very less as compared to that of the gun, understand? So the velocity is depends on the mass of this. Now the mass of the gun is very large as compared to that of the bullet. So bullet move very fast, so the velocity also increases it. okay, very fast from the gun, because okay, the magnitude as compared to the mass of that bullet is very high. But at the same, even though the magnitude of applied by the bullet on the gun is same, but the gun will not move backward because the mass of the gun. Understand? This product will remain always same. That is the momentum, you know that. That is the we will study in the next class. The same here, the many examples, such example is there. Now you know that why the tank and all. Okay, that is so huge it is. Okay, because of in order to avoid this recoil velocity it is made. Understand? This whatever the tanker we are using for the this for this war and all. Okay, you know that. Okay, it is very huge. It is made very huge. Why? Because in order to increase its mass, so that even though the bullet is fired from the tanker, okay, the tanker will remain there only. Okay, so that because of the okay, it is having the higher mass. Understand? So that it is very important. Okay, this recoil velocities. The same case is the rocket also. While rocket is moving upward. Okay, how the rocket is moving upward while telling about. Okay, same the third law of motion is using. Now you know that when it is so ignited, if the launching of rocket you see, you can see that there is lot of smoke around it. Okay, that is why, because when the this rocket is launching, okay, when the fuel is fired, okay, ignited, okay, there due to the chemical reaction, okay, inside the rocket, what is happening, okay, a chemical reaction, what is the smoke is emitting, okay, from the rocket through a small nostrils, we can say. Okay, then because of this, okay, a huge pressure is applied on the earth, that is a force is applied on the atmosphere, we can say. Okay, so then the air surrounding that, okay, will apply an equal and opposite force on the rocket. Understand? Now the mass of the rocket is relatively less, okay, with respect to the earlier, because of the rocket, from the rocket, okay, some fuel is ignited and that smoke is came out. Understand? Okay, so that okay, it will push, the atmosphere will push this okay, rocket upward and the rocket will go forward. Understand? So it is a vertically it is going upward. Okay, so it is like, so such a very important okay, law, this third law of motion is. Okay, other one example we can see that, okay, when we are moving out of, even you know that especially, okay, a sailor and all is moving out of the boat, okay, you can see that the boat will move backward. Understand? Why? The if we are not that is get out of this boat properly, obviously we will fall. Understand? Why it is happening the same thing? Okay, that is here when we are applying a force on the boat, okay, then what actually will happen is, okay, because of the recoil velocity, the boat will move back. Understand? Then we will move forward. Understand? So like that, okay, many examples is there of Newton's third law of motion. Okay, you read the textbook. Okay, one more part is there that we will see in the next class. Okay, very important. So what is third law of motion? If somebody is asking, what we have to tell is, okay, for every action there is equal and opposite reaction. That is very important. Okay, and other thing is that, okay, that is this are equal in forces applying, are equal in magnitude. It is applying on the, okay, on another body, that is not on the same object. Okay, then the other is the direction is in opposite. Understand? Even though the magnitude is equal, okay, there is a movement, there is an acceleration. Okay, why? Because of the mass. The mass of one body is relatively less than the other body. So whichever the mass is less, that will move. Okay, other will also move, but relatively the movement, the velocity will be less. Understand? So that is about the third law of motion. Okay, I hope all of you understand it. Okay, study it well. Okay, read it well. Okay, make a lecture note also. Okay, for today it's enough. Bye. Have a nice day.